purpose of this podcast is not just to discuss books, but also sometimes discuss ideas, the powerful ideas around us. And what more powerful idea could there be in medical sciences or biology than that of evolution? But unlike some of the other powerful ideas in science, such as that of Big Bang or black holes, this one gets a lot of criticism and, in fact, gets hammered sometimes in certain parts of the world. This has been excluded from the curriculum because it threatens some of the old ideas of the world and what we are doing in this world. Some people believe it makes their existence almost meaningless. So, while some people still try to merge this idea with their idea of God or religion, others find it difficult to do that, and therefore they completely ignore or ban the whole idea of evolution. Philosopher Dan Dennett has described it as universal acid because this kind of destroys and eats through just about every traditional religious idea. So, what is this exactly and what is it all about? Is it just a theory and may not be true? Let's talk about these possibilities. First of all, this idea of evolution, this comes in two parts. One is the theory of evolution and the other one, the natural selection. I will talk about both of these things one by one and then eventually put them together. On a very fundamental level, the theory of evolution states that species like ourselves, we change and we give rise to another, which is to remember that we are not constant static things, static species. We evolve. Of course, this process takes millions of years, very long time, so you cannot really observe it with your naked eyes, as some people claim that why aren't we seeing with our eyes turning monkeys into humans. I'll come to that point later, but it's a really long process. So see it like a seed. A seed, you plant it and eventually it grows into a big tree. That is how this view sees life on earth. That life began on a fundamental level, then eventually it grew out in different branches. On one branch you'll find one kind of animals, on other branch you'll find different set of animals, but you will find the common connections. So for example, there are two adjacent branches which are neighbor to each other, which have common ancestor, and then at some point they diverged, so they started having different species. And similarly, for multiple branches you can find the common points and eventually you can trace back all the life to one common source. Now, as you can see, this is not really a difficult idea. It's a very simple idea, but as I said, it's controversial because it challenges some of the fundamental beliefs of people about who they are and what they are doing on this planet. And to be fair to the people of the past, it's very difficult to observe these kind of processes with their own eyes, and that's why they didn't believe in it. For example, Aristotle, he concluded that species cannot change into one another. Monkeys will be monkeys and humans will be humans. But as science developed, sometime around 18th century, people started concluding that yes, monkeys are monkeys and humans are humans, but things can change given enough time, and this bit is very crucial. And that is something we have discovered over the period of time. In fact, in the last 15-20 years, we've had far more evidences than we have ever had in the past through fossil fuels, through genetic research, that how the species are interlinked. And in fact, if we were independent, most of the medical research would have been impossible. And that's how we conduct tests on animals and then eventually develop medicines and vaccines for human beings. In fact, some of the carbon dating evidence suggests the same. If all the species were created at the same time, we would not find the order in which we find the fossils. So that also is enough of an evidence. One common objection that you'll find in this topic is sometimes when people say that where are the intermediate species. For example, when there is monkey and there is human, where is the intermediate species between the two? And the answer to that is pretty simple. For example, you have, let's say, a fruit, and then somehow you modify it through your research, genetic research, and agricultural practices, then you develop a new fruit. Then you will have two different fruits. But the intermediate would always be missing. Whatever species you have, you can always find this question that where is the intermediate between these two? If there was intermediate between two, then you would ask another question, same question, that where is the intermediate between these two? So at a given point of time, you will always see the end result, the species itself. You won't see the journey, how that species have developed or evolved. And last point, that the people say that it's just a theory and there is not enough evidence. As I said, there has been enough evidence now, and almost all the biological sciences pretty much accept this, just like any other fundamental law in physics. In fact, we should remember that a theory in physics is not how we use it in or theory in science in general. It's not something how we use in our real life, that theory somebody throws up in the air and there's no perfect evidence for that. Scientific theories are tested time and again until we find enough evidence, and then the scientific community accepts them. So there is no problem here. But the real one is, how does this happen? How does the evolution takes place? And that takes us to the second part of the discussion, which is the natural selection. What is this natural selection? I think a lot of people talk about it, but very few, at least in the common public, understand how this works. And Darwin made a huge contribution in that, because as far as evolution is concerned, or the changing species idea was concerned, it was there. Apart from Darwin, many other scientists, they were talking about this, but very few had this idea. Very few worked on or successfully worked on how this works. So natural selection, the simple and powerful idea, changed the approach in which we viewed the evolution. So let's just very simply understand what is this, how does this work. So first of all, we must remember that natural selection, it takes place when three they are met. The first condition is there is a population of things or species that make copies of themselves. One. The second condition is the copying process is not perfect. And the third condition is the copying errors lead to differences in the ability of offspring to survive and make copies of themselves. And the reason I said not just the species but things, but because it can apply to anything that can copy itself. Computer viruses can copy themselves, therefore, computer viruses can evolve by natural selection. But let's focus on animals and living beings. So consider small animals, any kind of animal you can imagine. They make copies of themselves, that is, they reproduce. The copying process is not perfect. The offspring would be different in some ways from the parents. And the third one is these differences in the offsprings will determine the chances of them having offspring in the future. In the philosophy of science or philosophy of evolution, this is illustrated with a beautiful story. Let me tell you that. So once upon a time, there was a population of pale butterflies which lived in England. When the butterflies sat on the pale tree branches, birds sitting on those trees could not spot the butterflies very easily. Then one day, some industrialist, he builds a factory near those trees, and all the branches turn grey because of the pollution. Now the butterflies, they were no longer hidden when they sat on the branches, and the birds on those trees, they were now able to spot the pale butterflies easily against a dark grey background. So the butterfly population began to decrease because more and more of them were getting eaten by the birds. The butterflies then continued to have offspring, but they did not live very long. But since the offspring of all the butterflies were not exactly the same, some had developed different colors. So eventually, as I said, they were getting eaten by the birds. However, when there was a grey butterfly or two on the branch, which were born because of some defects, some kind of genetic changes, there is a lot of processes that go on, and because of that, as I said, these butterflies have different colors. All of them are not exactly same. Maybe there are here and there variations. So we have grey butterflies, and those very few grey butterflies, when they're sitting on the grey branches, then they were getting saved because of that color, and birds were unable to eat them. And now, over the period of time, we will see a rise of grey butterflies, and suddenly the population of grey butterflies grew immensely in that area. This is what we refer to as natural selection. And this is what makes it even more dangerous than the theory of evolution, because in evolution we can still say, as many people do, that evolution is happening because of some kind of magical or God's interference. But this suggests that is happening on its own because of the events around a species' surroundings. And as you can see, the same process gets replicated from species after species. For example, we as species, and that is human beings, when we were living on trees, and suddenly those of us who came down and used our feet, so then the groups of people which were not exactly human by then, they had advantage in certain areas, so they started wandering, and eventually over thousands and millions of years they evolved into from something similar to animals to something similar to what we call as human beings. And this story goes on for almost every species on the planet. Why almost? In fact, every species. You see dogs around you, they were evolved from wolves. When at some point in human history, some wolves were domesticated. Those were the nice, obedient wolves, and you can see the. In this case, however, we selected. There was not the natural selection. We selected particular breeds, particular kinds of dogs, the ones which were more obedient, which were nice, probably less aggressive in certain cases, and then and we discarded the other ones which we found dangerous, and eventually we had dogs, and nice dogs. And you find over the period of time, dogs have become much nicer, and in fact those breeds are growing. So that is how eventually we find human beings on this planet. And so that's the story of evolution through natural selection.